Hi again. I thought that with bringing back some projectile motion and circular motion, that it might be good for us to take a little crash course on just revisiting some facts that we need to know to do these problems. So for instance, projectile motion, we want to make an XY chart. And things that are always true is that the horizontal acceleration is 0, the vertical acceleration is the acceleration due to gravity. If we're trying to hit a target or mastering physics on Earth, it would be negative 9.8. We have a starting x velocity and a starting y velocity, and they're usually not the same number. We have a delta x, which is the horizontal range that something goes, and a delta y, which is the change in height that the object has. And then we have the time that the object is in the air, and this is the only thing that is the same for both objects. For a projectile motion problem, we need to remember that there's only one place in only one of the velocities that's equal to 0. We would say that vertically we have a starting velocity upwards if we're launched at an angle, and that vertical velocity gets smaller, and that vertical velocity gets smaller, and only at the top, just for a second, is that vertical velocity equal to 0. That vertical velocity then turns around and starts heading back downwards, and at the same height, you're going the same speed, but just in the opposite direction. Notice that right before you hit the ground, your velocity is not 0, only at the top of the path right here. Like you could call that like your maximum height. That would be a place that your y velocity is equal to 0. Now your x velocity is actually not 0. Your x velocity is constant. Whatever your starting x velocity is, you keep that x velocity the whole time. So you keep moving forward the whole time. If we ask you for the final total velocity, we're not asking for the x or the y. We're actually asking for like the hypotenuse of this right triangle. So we would have vx squared plus vy squared equals, and we would be talking about this right here, this final total velocity. Again, notice that it's not 0. It has both an x component and a y component to it. So what are the tricks to solving a projectile motion problem? Well, if we are going to be launched at an angle, like the one that I just drew here, one of the tricks is that the delta y is equal to 0 when you start and end at the same height. The other trick for projectile motion, another like hidden given, is if you just launch something horizontally. If you just launch something horizontally, you're basically starting it right here. You're saying all of this didn't happen, and I'm just only looking at this portion right there. This is the portion for launched horizontally. So again, something that's launched horizontally starts with an x velocity. That's its launch velocity. But the starting y velocity is 0 anytime that something is launched horizontally. Now, as it continues to go, the x velocity remains constant, but the y velocity starts at 0 and gets bigger and bigger and bigger on its way down. But knowing something that's equal to 0, knowing that when you launch horizontally, your starting x velocity is your starting velocity and your starting y velocity is equal to 0, those are like the key factors for a horizontal launch problem. And when you launch at an angle, the key factor is that you start and end at the same height. In both of these problems, in order to solve for the time, you use the bulldozer in the y direction. You use your y information to solve for the time. So if you're launched horizontally, your y velocity is 0. This height that you fall is the height that you fall down. So it's like negative the height of the table. And then you just plug in what the acceleration due to gravity is. And so as long as you know the height and the acceleration due to gravity, if you're launched horizontally, you can solve for the time. Once you know the time, you use the bulldozer in the x direction. And in the x direction, the acceleration is always 0. So once you know the time and that x velocity, you could solve for the range. That same process is true when you launch at an angle. It's just that when you launch at an angle, you use the y bulldozer to solve for the time. But the y starting velocity isn't 0. The thing that's 0 is the delta y. So 0 equals 1/2 gt squared plus, this is an actual number now, times t. And then you have to do that math where you pull out a t. And what I mean by that is you can either, do the bad math where you cancel the t, or you can distribute it out. So 0 equals t times 1/2 gt plus vy0. And now your two answers to make it 0 are as if t is 0 or if the inside is 0. So again, you would just set 1/2 gt plus vy0 equal to 0. And so again, if you know the starting height and the velocity, starting velocity in the y direction and the g value, you can now solve for the time. Always once you know the time, you use the bulldozer in the x direction to solve for the range. And that's just a little Cliff Notes version of projectile motion in case you forgot.